Assalamualaikum warahmatullahi wabarakatuh. Sorghum is a nutrient-rich grain that's high in fiber and antioxidant, but it is still remain underused in food product. We want to develop sorghum tempeh nugget because we want to deliver sorghum benefits such as its high fiber that can support digestion. We also combine it with texturous vegetable protein and vital weight gluten. This support with previous study where TVP and also vital weight gluten can enhance texture and also sensory acceptability in meat alternative. Although sorghum has antioxidant potentials, its pH activity, taste, texture, and sensory acceptance is still not well studied. There's also a limited information on how cereal and legume can affect the texture and also microbial quality of meat analogues. At the same time, low fiber intakes, especially in children's and modern diet, can lead to digestive issue. So a high fiber meat analog like this could help to improve and also address this problem. The objective of this study were first, we want to compare the chemical properties of sorghum-based tempeh nugget and also soy-based tempeh nugget through crude fiber and also antioxidant analysis. Second, we want to evaluate the sensory acceptance through hedonic test. And third, we want to determine the microbial quality through yeast and mold count. And finally, we want to analyze the texture using a texture analyzer.
For methodology, sample were prepared using two types of tempeh, soy tempeh and sorghum tempeh. For formulation, we developed control F1, F2, and F3. All samples were evaluated through a hedonic test sensory to determine consumer acceptability. The best formulation was the future analyzed for chemical properties, TEMPEH assay, group fiber, physical characteristics, texture profile analysis, and microbial quality, yeast, and mold count.
Hi, Assalamualaikum everyone. Next, I will explain the methodology used in this study, which involved two main stages, the fermentation of sorghum tempeh and the preparation of sorghum tempeh nugget. For fermentation, sorghum grains were soaked for 24 hours, boiled for 20 minutes, and dried. Then rice flour and RHIZOPUS oligosporus were added before incubating at 30 degrees Celsius for 48 hours, until white mycelium appear. For nugget preparation, the fermented sorghum tempeh and TVP with steam, blend and mix with dry ingredients like vital wheat gluten, salt, and spice. The dough was shaped into 25-gram nugget, steamed again, plus frozen, coating with breadcrumb, and stored for further use.
For the sensory evaluation, formulation 1, which contained 40% sorghum tempeh and also 30% TVP, received the highest overall score. There were no significant difference in terms of appearance, color, aroma, and also softness. Even though softness, formulation 2 received a bit better acceptance. But there was a significant difference in terms of taste and also overall acceptability, where formulation 1 was rated as the best compared to control, which received the lowest score. In crude fiber analysis, formulation 1 had slightly higher fiber content than control, and the difference was statistically significant. The higher fiber level is due to the sorghum's natural cellulose and hemicellulose, which can also improve texture. This aligned with Sairong Omar reported that sorghum-based products such as bread have higher fiber content than those made only from wheat. This shows that using sorghum can increase the nutritional value of the nugget. For the VPPH assay, formulation 1 recorded lowest scavenging activity around 56% compared to control and also standard. The reduction is likely because sorghum's phenolic compounds are tightly bound within the grain, making them less extractable, while soy fermentation releases more free bioactive peptides and also isoflavones that enhance antioxidant activity. However, it still shows moderate antioxidant activity, meaning sorghum remains a functional and sustainable ingredient in nugget.
So for texture profile analysis, first formulation 1 showed higher hardness value compared to the control. Second, there is no significant difference P less 0.05 in all texture parameters between control and F1. Third, both samples record very low addition value. Lastly, F1 appearance slightly firm and more elastic.
Next, I would like to share about the yeast and mold analysis for our product, the sorghum tempeh nugget. This analysis was carried out to ensure that the fermentation process was well controlled and that our product maintained good microbiological quality and safety. After 7 days of incubation at 25 degrees Celsius, the results showed that formulation 1 had very minimal yeast and mold growth. while the control sample showed no growth at all. The slight growth in formulation 1 could be due to natural airborne spores or from the fermentation process itself. However, the values obtained were still within the acceptable safety range, proving that our preparation, handling and storage method were effective in minimizing contamination. Overall, this analysis confirmed that our sorghum tempeh nugget is microbiologically safe, stable and has strong potential to be developed and commercialized as a healthy plant-based food product. Moving on the impact of this project, we successfully developed sorghum tempeh nugget that are high in fiber, nutrition and promote a balanced diet. The product show good microbiological safety with slow yeast and mold growth, ensuring quality and stability. From the sensory evaluation, it was well accepted in terms of taste, texture and appearance. Overall, this innovation supports sustainable food development by using local sorghum, promoting eco-friendly and resource-efficient practice.
Based on the result achieved, it is proven that our sorghum-based tempeh nugget is a promising meat analog with high sensory acceptance, improved fiber content, acceptable texture, functional antioxidant professional, and safe microbial quality. The product showed the moderate substitution with sorghum tempeh provide balanced flavor, apparent and desirable texture. However, scientific is a soy-based. Future improvement should focus on developing soy-free alternative and optimizing frying and moisture control to enhance antioxidant retention and shelf stability, making the product healthier, allergen friendly and more sustainable.